Hello, how's it going? My name is Tyler Mann. I'm doing homework number 1, problem 3, and that is to prove that A and B are independent, given that the probability of A given B plus the probability of A bar given B bar equals to 1. All right, so we're going to start off with the given and convert it using properties of conditional probability, as you can see here, to probability of the quantity of A times B over the probability of B plus the probability of the product of A bar B bar over the probability of just B bar, again equaling to 1. Again, I want to repeat, we use the properties of conditional probability, and you'll see that as I keep moving along, the previous conversion will be on the top of the page, such as right here. So I don't need to explain that. So we're continuing on from here. We're using De Morgan's law in order to expand the second term of the first row, as you can see right here. And we're expanding that to the probability of A plus the probability of the quantity of A plus B bar over that quantity over probability of B bar. And again, you have the same term right here. And again, equaling to 1. Okay. So we're moving on. After expansion using De Morgan's law, we use an axiom of probability to convert the second term. And you'll see a theme here that we just kind of work on converting the second term. And when converted, it equals to 1 minus probability of A plus B over 1 over the probability of B bar. And I might have forgotten an equal to 1 right here, so let me add that. Okay. So there you go. You can see that equals to 1. Same thing. All right. So we're going to continue on with this right here. Again, messing with the second term, manipulating the second term. We expand the second term using an axiom of probability to 1 minus the probability of A minus probability of B plus the probability of AB over probability of B bar. Again, the first term right here stays the same. Again, I forgot to add the 1, as I always keep forgetting to add. So let's do that. See? All right. Any questions, just put it in the comments section. Okay, so we're going to continue on from the previous, right here, the previous conversion. Again, we're going to mess with the second term. We're going to separate it, in fact, to a probability of A, B over probability of B bar, plus the probability of 1 minus the probability of A, minus probability of B over the probability of B bar, as you can see right here. This whole thing is the second term. I just kind of separated it out. This is still the first term, and we're going to move on. Right here. So you can see the separated term right here. We're actually going to combine the first two terms. We're going to mess with the first term now, and we're going to factor out the probability of AB to give the probability of AB times the quantity of 1 over the probability of B plus the 1 over the probability of B bar. Sorry, let me repeat that. So we're going to factor out probability of AB times the quantity of 1 over the probability of B plus 1 over the probability of B bar, close parentheses, plus this term right here, which is the probability of B bar minus probability of A over the probability of B bar, all equaling to 1. Oh, and I guess in the previous one, I forgot to add 1 as well. I keep forgetting. I apologize. Okay, so moving on. We have the probability, again, you see this. This is what when we factored out probability of AB, we're just basically messing with the terms. We rearrange both terms so that we make this to have a common denominator right here. We put the probability of B bar over the probability of B bar, which equals to 1 right here. And you subtract over the probability of A over probability of B bar. Basically, it's just rearranging terms, so I'm going to have you look at that for a second. Okay, great. All right, next. All right, so we're going to take that one, and you'll see I've messed with the first term, as I've previously not done. The probability of AB times the improper, I don't want to say call improper fraction, but this term right here over the probability of b times the probability of b bar. So the probability of b plus the probability of b bar actually equals to 1. So as shown here, the ones cancel out on both sides of the equal sign, and we're still left with the probability of a over the probability of b bar. And ultimately, this is what we get, because when that equals to 1, you can just multiply that out, and you get this. And the final step is we manipulate this fraction, this proportion, I want to say. Cross out both the probability of b bars at the bottom, because if they're both at the bottom, they equal the same thing. Cross multiply pb, probability of b, times probability a, and that's what you get to prove that a and b is in fact independent. Thank you for listening.